Okay, this is our bell work problem. Okay, I'm going to answer questions on lesson 3.4. Lesson 3.4. So give them to me. Okay, so this is number 19, and it looks like what we're doing, we're giving this one in radical form, and we want to change it to exponential form. Okay, so we have to write it as rational exponents. And then it says to write it in its most simplified form as well. So if I'm looking at this, does anybody have any ideas on what we can do to any part of it? Branson? The 5 under the what? The 13, the 15? Okay, now you have to do that. That's partly right. But see this 32? You also have to take the fifth root of 32. Okay? Now, here's a suggestion first, you guys. I would suggest rewriting 32 because 32 can be written to some number to some power. Besides Alex, because Alex always knows the answer. Who else knows? I wanted to see how many of you. Something to a power is 32. A number raised to some power. 2 to what power? The fifth power. That's right. Okay? So we can rewrite this as 2 to the fifth power times x to the 13th power. Now, we might be able to do the same thing with 243. Okay, does anybody else know besides Alex? I'm going to let him go in just a second, but I want all you guys to have a chance to think about it. 243. Everybody, you know what? I'm going to have everybody do it. Play around with it for a second. See if you can find. Okay, good. You guys got 3 to the fifth power. Y to the 15th. How do you come up with a number like that? Is that what you're asking? Well, what do you mean? Divide 243 by what? Well, what I do on something like this is I'll start with like 2, and I'll go, and well, I was pretty sure, I could be pretty sure it's not going to be 2 because it's not an even number, right? So I would go to 3, and then I'd go, I already know that 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81, okay? And if you don't know that, just start putting them in your calculator and build up until, if you pass 243 without hitting 243, you know it's not 3, right? And so you start with another number. That's just a guess and check way, but by the way, the more you do that, the more familiar you'll become with numbers, and it'll get easier to come up with these. I looked at 243 right there, and right off the bat, I was pretty darn sure it was 3 because I've had experience. So the more you do it, the easier it gets. So 3 to the fifth power. Now I can rewrite it as my rational exponents right here. So I can write 2 to the 5/5 power times x to the 13/5 power. Just like Branson was saying, we can put a 5 under the 13 and a 5 under the 15, okay? 3 to the 5 over 5 power and y to the 15 over 5 power. Because since the root was, the index was 5, it's a fifth root, that 5 becomes the denominator for each of those. Okay, so now, I think you guys can kind of do it from here for the most part. 5/5 is equal to what, you guys? So it's 2 to the 1 power, which is just 2. Now, here's the deal. How many times does 5 go into 13? 2 times. So I know that I'm going to have an x to the 5/5 times an x to the 5/5 times an x to the what? 3/5, right? Think about that. Because 5 will go into 5, and we just add the exponents. 5/5 plus 5/5 plus 3/5 makes 13/5 because we're going to add those. Because the rule is if you have x times, the base is all the same, and you're multiplying, you just add the exponents. Okay. Now on the bottom, 3 to the 5 over 5, which is just 3. Now how many times does 5 go into 15? So what could I simplify that to be? Y to the third Now, I wrote the whole top out. I could have done this without writing the whole top out, but x to the 5/5 is just x to the 1, right? So it's x to the x times x times x to the 3/5. How can I simplify that? 2 times, not 3x, x squared, because 5/5, that's x to the 1 times x to the 1. That's just x times x, which is x squared, right? Yeah, the exponents. And times x to the 3/5 all over 3y to the 3rd. Now, sometimes they might just leave that x to the 13/5 as x to the 13/5 instead of writing it 2x squared times x to the 3/5. Okay? Which way is confusing? This one right here, this answer, or the top one? X squared times x to the 3/5 is more confusing than just x to the 13/5. I would have to agree with that, but it just depends. I honestly don't know if they were wanting us to go right here, except for that's going to be 2 to the 1st and 3 to the 1st and y to the 3rd. You know what? I just got an email the other day, and they said they just completed answer keys and everything. So I am going to, huh? Yeah, they did. But they're selling them, so I have to go buy them for $68. So I'm going to buy them though. So we have them. Okay, so you know, it just depends on how they want it. So really, technically, they could have wanted the answer as x to the 13/5, 2x to the 13/5 over 3y to the 3rd. I actually like that way better. Okay? Any questions there? Okay, let's go over to problem 24 now, was it, Kelvin? Okay, 24. 24 says, given the function, find the x-intercepts and y-intercepts if they exist, and then use them to graph a sketch of the function. So I'm given g of x equals 5 times 2 to the x minus 1 power. Now, do you guys remember how we find x-intercepts or y-intercepts? Yeah, we plug a 0 in for the opposite one we want. So if we want the y-intercept, let's do the y-intercept first. If I want to know what y is, I'm going to plug, and I'm going to replace g of x with y. I'm going to plug 0 in for x. How does that affect that problem? How do I simplify it? Well, it's going to be 5 times 2 to the negative 1 power, right? Now, how do I get that to not be a negative exponent? Okay, so I put it in the denominator. 5 over 2 to the positive 1 power. And 5 divided by 2 is 5, 2.5. So my y-intercept is 0, 2.5. That's my y-intercept, right? Because the x-coordinate is 0 at the y-intercept. How do I go about finding the or the x-intercepts? Set the whole thing and replace y with 0, right? So 0 equals, I'm going to use a different color. 0 equals 5 times 2 to the x minus 1 power. Now, let's use our skills to kind of do this. First of all, can I divide both sides by 5? Yeah, you can. Yeah, you're going to get 0 equals 2 to the x minus 1. Okay. Could I use my rules of exponents to write that as 2 to some power times 2 to some power? Yeah, 2 to the x times 2 to the what? Negative 1, remember? That rule of exponents? And what's 2 to the negative 1 power? What do I do with that? I do what with it? Yeah, so 2 to the x power over 2 to the positive 1 power. Say that again. Yeah, anytime you have a negative exponent, you're going to move that whole thing. If it's in the numerator, you move it to the denominator and make it positive. So I move the 2 to the negative 1 to the bottom and make it 2 to the positive 1 power. Well, 2 to the positive 1 power is just 2. So then I have that. What? Yeah. Yeah. Let me ask you this, you guys. If I times both sides by 2 right now, I get 0 equals 2 to the x. Can you guys think of a number I can put in for x and go 2 to that power gives me 0? Yeah. If I put 0 in for x, what do you get? 2 to the 0 power is 1. Okay? Alex. The answer is it has no x-intercept. Exactly. Did you guys see this? This function's going to go like this. It's going to cross the y-axis at 0, 2.5. And do you guys remember that this thing's going to get closer and closer to the x-axis as it goes out here, and it's never going to touch it? There's actually what we call an asymptote right here, right along the x-axis. An asymptote is a kind of an imaginary barrier or line that the graph gets closer and closer to and never touches. Okay? So this one doesn't have any x-intercepts. Okay? So that's what it's going to look like. Okay? If you want to graph that in your calculator, if you don't believe me, go ahead. Well, how many of you guys know how to put it in your calculator? Let's go there. Whoops. So close to the x-axis, it never hits it. So it comes down, and it goes on forever that way and up forever that way. So it will never cross the x-axis. Okay, on problems 23 through 26, I want you to find the intercept, put 0 in for y. And to find the y-intercept, put 0 in for x. Yeah, to find the x, 0 for y. To find the y, put 0 in for x. Okay? Now, if you do that, you should be able to find all of your x-intercepts and y-intercepts and then be able to graph it. Okay? When is this assignment due? Next time. So it will be due next Tuesday, a week from today. Okay? So, hey guys, a suggestion. If you're struggling with this, I would go to Khan Academy. Have I showed you guys all how to get to Khan Academy? Okay? If you go to my website, that's playing Christmas music. Can you believe that? Okay. Where did my... Hey, Maddie, you want to go to my computer and type in AmericanHigh.org? Whoops, just click on there again, do it. Okay, you guys go to departments, go to mathematics, right there. I was starting to think they took it off. Go to my website. I have a Khan Academy Khan Academy. Okay, if you go to your class, second period honors, math 2, I have, wait, where did it go? My links all disappeared. I thought I had them on here. Oh, right here. Here it is. Over here. You guys up, upper right here. A good homework help site is the following: www.khanacademy.org. If you go there, this is just something recently. So now when you get on it, you have to sign in with either Facebook or something. Sign in with Google. So teachers start here, parents start here. You can start wherever you want. I don't care. You can start as a teacher if you want. I'm sure you can. Okay. Anyway, you go there. Or sign in with Google. Anyway, if you go in there, you can do a search. And what I would do is do a search for rational exponents or radical notation. Okay? Either radical notation or rational exponents. If you look right here at where it says set on your homework assignment, if you type in one of those, then you can search for a video that will teach you how to do these things, okay? And review a little bit with you. Got it? So we learned that this one is 63 square feet because there are 9 square feet in a yard, and 9 times 7 equals 63 square feet, okay? So the square is two-dimensional, right? You guys were all thinking one-dimensional. That's why you had 21 as your answer, okay? Because we got to think, when we're thinking about area, we got to think two-dimensional. Now, if you think three-dimensional all of a sudden, okay, how many of you guys know what a cubic yard is? A cubic yard, this is how you measure volume. This is volume. Now all of a sudden you have to come out this far. It would be a piece of cement block. If you were doing cement, it would be a cement block going out here like this, okay, from here up to there, from left to right, that way, right? Okay, now how many cubes would be in that thing? No? Huh? 27. Because you'd have on the first set, if I went out a foot right here, there would be 9 1-foot cubic blocks. Then another foot out would be another 9. And then another foot out would be another 9. There would be 27 cubic feet. That's like a Rubik's Cube. That's exactly right. The Rubik's Cube has 27 cubes if you count the middle one, right? Although you can't see it. Okay? So if there was a cube in the middle. So think of that. Now, when guys order cement, to pour cement, they have to measure it in cubic yards. And so they know there's 27 cubic feet in 1 cubic yard. Okay, and then this is what they do. They usually pour cement 4 inches thick. So each cubic foot would have how many square feet would it cover? 4 will go into 12 how many times? 3 times. So there's going to be 3 of those layers. You can cover 3 square feet with each cubic foot. And so since there's 27 cubic feet in a yard, you go 3 times 27, it covers 81 square foot feet is how much cement. Okay? And so you can cover an area of 81 square feet with 1 cubic yard. And so what you do when you order cement is you take the number of square feet and you divide it by 81, and that's going to tell you how many cubic yards of cement you have to order. Because that's when you call up the dispatch, the cement dispatch place, they're going to ask you in yards how many yards of cement you want. So that's how you do that. Okay. Okay. See if you can get these other two. Yeah, she's saying that there are 12, a foot is 12 inches. Did you hear what she said there? A foot is 12 inches. So if you have a square foot, and it's 12 inches on this side and 12 inches on that side. 12 times 12 is 144 square inches. So there's 144 square inches in a square foot, and you want 5 of those. So 5 times 144 would give you, say that again, 720 square inches. Okay? What about 1 mile? How many square feet in a mile, by the way? How long is a mile? Yeah, how many of you guys knew that off the top of your head, that a mile is 5,280 feet? So did you times that by itself? And what did you get? 878? And then what? 400? Square feet? So there's a lot of square feet in a square mile. Okay? We kind of get that idea? All right, there's 3 more problems like that on your assignment. We'll be doing. Okay, today, you guys, I'm going to teach you about the quadratic formula. Okay, now I don't know if you guys remember now that you learned how to complete the square of a quadratic equation. And when you take the standard form of a quadratic equation and you complete the square on it, on this thing right here, then you come up with a formula called the quadratic formula. And I want to take you through this. I want you to write this down step by step so you can study it later. But mostly, because you have to know how to derive the quadratic formula. Now, the reason we're not doing the task this time is because they teach you how to derive it in a different way. And for the sake of time, that would have taken us 2 days to do that. It actually looks like a really good way. I've never seen it before. But I'm going to teach you this way. And we're going to use the quadratic formula to solve some problems. Okay, so this is what we do right here. We're going to complete the square on this. We're going to put it kind of in vertex form. Okay, we're going to get x all by itself. Okay, in order to do that, first thing we're going to do is we are going to minus c from both sides. And on the left side, we are going to leave a space to complete the square. So we're going to minus c from both sides. And that's a what? You're talking about this thing? That's a 0. That looks like a, how do you get a q out of that? If I did this, it would be a q, right? If I write it like that, does that look better? Oh, right up here? That is a q. Okay, now I'm going to factor out, remember, when we put things in vertex form, we couldn't have an a right there. So we're going to factor out an a out of the first 2 terms. Okay? We got that step down? We factored an a out. Okay? Now, I have to come up with the number that makes this a perfect square. Do you remember how we did that? What did we do to this term? I didn't flip it. I took half of it, didn't I? Okay? So I'm going to take 1/2 times b over a, which is going to give me 1 times b is b, 2 times a is 2a. So I took half of it, and then what did I do with that half? I squared it. So I'm going to have b squared 2 squared. What's 2 squared? 4 and a squared. Okay, now whatever I do to one side, I have to do to the other. Before, when we were putting in vertex form, we would just minus it. But this time, I'm just going to put it on this side. Whatever I put on this side, I put on that side. Branson. Okay, all right. Now, I got to find out what I put on that side. Well, it looks like I put a b squared minus 4a squared on the left side, so to keep the scale, the balance scale balanced, I have to do it to the other side, right? Exactly. Shaden was saying, but I have to multiply that a back in because it's really a times this, right? Well, if I times this a by this, what's it going to do is the a on the top will cancel with one of them on the bottom. So really, I added a b squared over 4a to both sides. Megan. This 4 right here? This 4? Well, remember, to get the number that completes the square, you have to take half of b over a and square it. So half of b over a became b over 2a. Then when I squared it, that became b squared, that became 4, and that became a squared. Got it? And then say that again? Yeah, 2 squared is 4. Okay? Yeah, you got to square each part of that. Okay, Kyle. Yeah, so if I multiply this a by this, it will be on the top. It will say a times b squared over 4a squared. But what it does is this a right here will cancel with one of those down the bottom, so it's going to be b squared over 4a. Does that make sense? Okay, any other questions? Okay, now I'm ready to complete the square. A times, now the square is going to be x plus the square root of this number right here, which is already b over 2a. We know that. So b over 2a. And on the right side, I'm going to rewrite this as b squared over 4a minus the c out here like that. I'm going to write it like that. And actually, I'm going to get a common denominator. I believe I am. Okay, I'm going to get a common denominator on the right side. Okay, this a that was right here squared, how did I get rid of it right there? When I times this a by this, because that's really what I added to this side, is this times this. I have to add whatever that is to that side. When I times ab squared over 4a squared is what I got. This times this is this. This a will cancel with one of those a's, so it was left with b squared over 4a. Okay? Got it? Okay, now, you guys, I'm going to get a common denominator down here. So to get a common denominator, what's my common denominator between these two things so I can add them together? Remember when you add fractions or subtract fractions, you got to have a common denominator? My common denominator would be 4a. Okay? So I got to times the top by 4a and the bottom by 4a, because 4a divided by 4a is 1. So I'm just multiplying it by a 1. So now I have a. Oh, and by the way, I forgot the squared right there. Because when I factored this, it came out with two factors of x plus b over 2a times x plus b over 2a, and so it's squared. So a times x plus b over 2a. And then over here, I'm going to write this as equals b squared minus 4ac all over 4a. I can write it in that order, like that. And I can write it over one denominator. Oh, I forgot my squared again. Because it gets it into the quadratic formula that we're used to seeing. And you'll see why. Because now we're going to have to take the square root of both sides. Actually, before we take the square root of both sides, we've got to divide both sides by a. We've got to times both sides by 1 over a. I told you. You guys, yes. Okay? All right. Okay, now. No, yeah, it's going to cancel out over here. It cancels out. I'm going to rewrite this over here, you guys, so it's closer this way. X plus b over 2a squared equals, and on this side, if I times that together, I get b squared minus 4ac all over 4a squared. Okay, now we're getting close to the end. Yes, Branson. We're trying to get x by itself. We're solving this equation for x, so you guys will have a formula to solve any quadratic equation so that you can solve any quadratic equation by putting it in this formula. But I need to show you where we got the formula from. Why did you take out the c and put it b2 divided by 4a squared? Just go with me to the end and we'll show you. You guys, I'll tell you, where did I get the 1a? I had to get rid of the a on this side, so I times by 1 over a, so they canceled out. So whatever you do to one side of the equation, when you're solving it, you got to do to the other. Huh? Well, they canceled out right here, and 4a times a is 4a squared. Okay? All right, so now the next thing I need to do is I need to take the square root of both sides to get rid of this square. So I get x plus b over 2a equals, and I'm going to separate this. We just learned with radicals, I can separate that in b squared minus 4ac. And guess what the square root of 4a squared is? 2a. That's right. It's 2a. It's pretty good. Last part of this. Oh, by the way, when we took the square root of both sides, it made plus or minus. Okay? When you take the square root of both sides, anytime you take the square root, like right here, if I had x squared equals 4, what are my two answers to this? Negative 2 and positive 2, right? Negative 2 and positive 2. Okay, so the answer to this is plus or minus 2. Positive 2 and negative 2 would both work. If you squared them, you'd get 4. Okay? So that's why whenever you take the square root of both sides, you're always going to get plus or minus. What's the last thing I need to do to get x by itself? I've got to minus the b over 2a to both sides. So I'm going to get negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, we got one step left to get it into what the quadratic formula looks like. And that is, since they both have you have two fractions you're adding and subtracting together, and they both have a common denominator 2a, you can write it with one denominator. So it's all over 2a. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. This right here, you guys, is what you need to know. This is, if I can spell, this is called the quadratic formula. This is the quadratic formula right here. Okay? Now, Jimmy. Well, it depends on what a is. A is going to give you a different denominator. Okay? Now, let me just do this, and I'm going to show you how to use it a little bit, you guys. But this is called the quadratic formula, Branson. We took the square root, well, because when we took the square root of both sides, you remember we learned last time, if you have the square root of a fraction, you can do it separately as the square root of the top over the square root of the bottom. When we took the square root of the bottom, the square root of 4 is 2, and the square root of a squared is a, so we got 2a. because the top, you can't take the square root of the whole thing, because 4ac is not a perfect square over here. Yeah, you can't take the square root of that. Okay? All right, this is called the quadratic formula. So I'm going to write it on a new screen right here. Everybody write it down if you haven't. Now, you guys, am I going to ask you to be able to prove the quadratic formula on the next test? And the answer to that is no. I'm not going to ask you to do that. I wanted you to write it down because I wanted you to think about what we were doing right there. We were solving for x in a formula that had ax squared plus bx plus c. And we made it into a formula that we can solve any equation. I'm going to show you one problem, Branson, and then I'm going to ask you a question. Thank you. Okay, let me just show you guys this right here, and then we can get it. So let's say, okay, so here's the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I have ax squared plus bx plus c equals 0. If I have a quadratic equation that's in standard form, this is standard form, right? This is the quadratic formula. I can take a, b, and c, which are the coefficients. A is the coefficient of x squared, and b is the coefficient of x, and c is the constant. I can plug them into that and simplify it, and I'll have my zeros, or my x-intercepts. Got it? So let me show you a problem. Just to show you how to do it. Let's say I have something like x squared plus 4x minus 12 equals 0. Let's say I have this. Okay. Anytime you put a quadratic equation equal to 0, that means you're looking for the x-intercepts because you're putting 0 in for y. What do you think they are? Negative 6. Well, that one's too easy. Let's not do that one. Well, let's do that one. We'll do that because this one's factorable, isn't it? I didn't mean to put one up that was factorable. I ended up accidentally doing that. Was it? Okay. Yeah, because this one right here, actually, if you go negative 6, or positive 6 times negative 2, positive 6 times negative 2 is a negative 12, and positive 6 plus negative 2 would be positive 4. So this one's factorable, but I want to show you that you can also do it with the quadratic formula. The reason we have the quadratic formula is because not all quadratic equations are factorable. Do you see that? Not all of them are factorable. And so you have to have, this one is factorable, but not all of them are. So I'm going to show you on this one right here. Okay, so right now, what is A, B, and C? Let's figure out what A, B, and C are. 1, 4, and negative 12 are A, B, and C, right? Remember when I had you guys on the test, write down A, B, and C? Okay, that's the reason we did that is because we were moving up to this thing right here, quadratic formula. So I plug them in. All you have to do, you guys, this is 7th grade math right here, this part of it. Because all you have to do is plug them into something and simplify. And you've learned how to do that since you were in 7th grade, probably maybe 6th grade for some of you. Okay? So all we have to do is we have to go negative b. I think of that as the opposite of b. So what is b? B is 4. What's the opposite of 4? Negative 4. So it's going to be negative 4 plus or minus the square root of b squared. That's 4 squared, which is 16. By the way, you guys, if b is a negative number, which it's not right here, but if it is, when you square it, you're always going to get a positive number, aren't you? But I have a lot of students, they put it in their calculator, it'll be like negative 8, and they'll put negative 8 squared in their calculator, and they'll get negative 64. Because if you put negative 8 squared in your calculator, you will get negative 64. You should put it in as negative 8 in parentheses squared, then you'll get the right number, okay? So, over here, I have 16 minus 4 times A, which is 1 times 12, negative 12, right? Negative 12, which is C, all over 2 times A, which is 2 times 1, which is 2. All we have to do is simplify that. Now, that's going to come out to be a perfect square, I know, because it's factorable. So everybody, take your calculator and go 16 minus 4 times 1 times negative 12 in your calculator really quickly. You should get 64. that what you got? I always like to have you guys do it in your calculator because so many kids make mistakes when they do it in their head. You guys should know order of operation to simplify that. Okay, what's the square root of 64 now, everybody? It's 8. I'm almost done. What's negative 4 plus 8? 4 divided by 2 is 2. And what's negative 4 minus 8? Negative 4 minus 8, you guys? Negative 12 divided by 2 is negative 6. There's my two answers. That's not that bad. Okay, Branson and then Megan. That's just to show you how I came up with the quadratic formula. That's what I said, yep. Okay, you guys, I wanted you to see how we came up with this formula. So you understood that it just didn't, some mathematician just didn't make it up. They completed the square on ax squared plus bx plus c on this thing so you can get this thing, right? And so now you can use a formula to figure out all your equations. That's what we're going to be doing today. Okay? So let me do one more example. I want you guys in your groups to do this one. Okay, there it is. Try that one. Equals 0. Okay, so that's what you got when you put it in your calculator. Now, does 129 break down and simplify? Is it a prime number? Look right up there. See if it's on my prime number list. Or does my prime number list not go up that high? Okay, I think it is a prime number. Let's see. 9. Oh, no, 3 will go into it. Go 129 divided by 3 for me. What is that? That's 43? 43 times 3? Yeah, that's right. 43 is a prime number, right? Okay, so there's no pairs of numbers, so 129 is simplified. So guess what? Your answers are negative 7 plus the square root of 129 over 2 and negative 7 minus the square root of 129 over 2. Now, these are irrational numbers. In other words, it crosses the x-axis at not a whole number, right? So this is what I want you guys to do right now. I want you to see that you can put them in other forms, too. I want everybody in your calculator to go negative 7 plus the square root of 129 and hit enter before you go divided by 2. Don't do divided by 2, unless you put parentheses around the whole thing. Negative 7 plus the square root of 129, hit enter. And then hit divided by 2. Hit the divide sign by 2 and hit enter. What do you get? 2.178. Okay, and let's find the other one. Go negative 7 minus the square root of 129 divided by 2. If you guys are going to put it all in your calculator once, you've got to put parentheses around the negative 7 minus square root of 129. Okay, what else? No, they're both x's. You're going to have two x-intercepts. It's a parabola, right? A parabola crosses the x-axis sometimes in two spots. We're not finding the y. We know what y is already because we put 0 in for y. That's why the whole thing was equal to 0. Okay? What is the next one? So if we rounded it to 3 decimals, negative 9.179, does everybody agree with that? Yep. Is that what we got? Okay, now, on your assignment, I got to tell you how we're going to do this, okay? Because they taught a different method in your book, these problems are a little bit different. Problems 1 through 6, we did 1 through 3 already, by the way. Did you guys notice that? 4, 5, and 6 are just converting as well, so do those. Go to problems 7 and 8. Everybody look at 7 and 8 on your assignment. I handed some to every table. Problem 7 and 8, I want you to find that And I want you to see if you can figure out the x-intercepts just by following what they did up there. If you want to use the quadratic formula on there to do part D and E, go ahead. Okay? On 7 and 8. Okay, then go down to 10, 11, 10 through, what is it, 10 through 15? It says use the given functions to find the missing values. Check your answers. Some of them you're finding y-intercepts. Some of them you're just finding values. And some of them you're setting them equal. If it says f of x equals 0, you're solving the equation. Or f of x equals 20, you're solving the equation. Just set it equal to 0 before you put in the quadratic formula. I want you to use the quadratic formula. Okay? All right, good job.